Hello, so today we will be testing the route optimization system, and we will be using this table to help us test it. So this just states each test that needs to be done. Now, in essence, the route optimization system is basically a platform where you as a user can enter in your manually created graph, and then you can pass it in through any one of these optimizations, and the system will tell you the result of performing that optimization on your graph. So we're going to make sure the system actually works and does what it's supposed to do, and we're also going to make sure that it deals with perhaps things that are a little bit unexpected from normal inputs. So we're going to go through each test. A key note about these videos is they're each going to last 10 minutes due to the software I'm using. It doesn't allow for more than a 10-minute recording. I'm sorry about the inconvenience this may cause, but everything will be put in a playlist to make it easier to access. And let's begin. So the first test is in creating the graph. So this is just a window which is involved in forming your graph. Okay, so it asks you for how many nodes your graph has, the weight of each edge of your graph. Okay, and we want to make sure that the number of nodes inputted is between 3 and 7, and to see why this is the case, the design part, the design document explains this in the UI section a bit more. So we want to begin by testing the number 5, because this is a normal input and we should expect it to be accepted. So if I go here, now another key thing to note is you're probably wondering, are we going to have to click on each one of these optimizations to test, our first test? And no, because whichever one of the optimizations we click, it leads to the same subroutine in the back end where the number of nodes is collected. So we can click on any one of these and our test would be valid. We don't need to click on each of them. I hope that makes sense. So if we enter 5, we can see it's accepted it because it's disabled this button and it's moved on to the next step of asking the weight of each edge. So that's good. The second test involves entering 3 and 7 for the number of nodes, and we should expect the input to be accepted, and this is an extreme test because we're testing each end. So if I enter a 3, we have accepted it, and if I enter a 7, it also works, which is wonderful. Now, test number 3 involves entering 8 and 2, and we should expect our input to be rejected. These are invalid entries. So let's try that. So if I enter an 8, we can see that an error box pops up saying an error has occurred, and it also tells us the issue. So it says please enter a value between 3 and 7 inclusive. If I enter 2, the same error box occurs, so that works, and we can pass these first 3 tests, which is wonderful. So the number of nodes works. Now test number 4, if I move on to this one. Test number 4 involves the same window with the exception of selecting Bellman-Ford. So this test involves checking that the weight of each edge is a positive rational number. Now the reason why Bellman-Ford is an exception is because Bellman-Ford can take on negative edge weights. So the Bellman-Ford test will happen later. But for all the other optimizations, if we enter a 7, the input should be accepted because that is a positive rational number. So if I come here, if I come here and we're on a directed graph, that's fine. If I enter, let's enter 7 nodes so that we have enough edges to work with for this part of the validation. So if I enter 7, the input is accepted because this button is disabled and it asks for the weight of the next edge. Then, if we enter 5.75, the input should also be accepted. This test is making sure it's not just whole integers, it's any positive rational number. So if I enter, oh, wrong one again, sorry. So if I enter 5.75, it also works, which is wonderful. Then if I enter 0, it should also work because 0 is an extreme value, and remember, 0 indicates that an edge doesn't exist, so that works, wonderful. Now, if I enter -9 or edges or anything that isn't a valid entry, our input should be rejected. So let's try -9. -9 gives a negative message box, and it says please enter a valid edge weight which is positive for your chosen algorithm. So if we enter edges, we have a message box saying error occurred, please enter a valid edge weight. So that's good, that works. So we can tick these tests off as passing because they work, and they all have the exception of Bellman-Ford. Okay, so I'm just going to check how long it's been. It's been 6 minutes. Okay, so then we are moving on to the next stage. Now this is still in the creating the graph sort of windows, but it doesn't work for prims or crystals or root inspection or branch and bound. And the test is checking that the start and end nodes are in the given range required. Now this test is only valid, if I return to the main menu, for the shortest path optimizations, because these shortest path optimizations involve finding the shortest distance from two given nodes. So we need to state as a user what those two given nodes are, and we call them our start and our end nodes, and this test isn't valid for these four because they don't have start or end nodes. So the first test is for an input of a graph with 5 nodes, B will be entered as the start node or end node, doesn't matter really, and we should have the input to be accepted. Note the system allows the start and end nodes, or the system allows the start node to be alphabetically more than the end node. So if my start node is E and my end node is A, that's not a problem, and if it's the other way around, that's also not a problem. So if I enter B for an input of a graph with 5 nodes, so if I enter 5 nodes, 1, 2, 3, 4. I'm just assigning random edge weights. That doesn't matter. Not too concerned with this currently. So if my start node is B, that's accepted because, well, it works, and it's now asking us for the end node. If we then try our extreme values of A and E, it should also work. Note this is a test within a test because you can see we're trying an uppercase E, so we're also testing with number 9 whether uppercase and lowercase letters work, and they should do. So if I enter A here, we move on to the result tab, which is wonderful, so that works. Just checking the time. Okay, I can quickly do the big E test. So again, it's 5 nodes, 2, 4, 5, again just assigning random values, and big E should also work, which it does, which is wonderful. Now we have less than a minute left, so I'm going to end this recording here, and I will see you in the next recording where we move on to test number 9. So test number 8 works. Oh yeah, test number 8 and 9 work, so test number 10. So I will see you then.